I'll speak quickly then. So it seems inappropriate to start a lecture like this with a gratuitous video, but that seems like the thing to do. So this is the embarked test.
Star 3, flying ready for departure.
Top Star 3, flight above government tower, clear for takeoff 73507.
So that is what the teams are doing this week, what they're doing next week, and what they do week in and week out, all year, every year, to try and train flight test professionals, that's test pilots and flight test engineers, to be ready for the challenges of flight test. So the question, as the CO and as a member of the family of COs of the test pilot schools, the question that we're wrestling with at the moment is, what is a test pilot? Now that's also what is a flight test engineer, but it would take too long if I keep saying and flight test engineer as well as test pilot. But what is a test pilot? I don't have the answer at the end of this lecture. And whilst you might not be asking questions, if you do have any answers for anything that I propose, please shout them out. I have a pen, and I'll take credit for everything that you say. What is a test pilot? That's a test pilot. So that is the classic test pilot role, the classic test pilot skill, based on the same training that you would expect from the 1950s and 1960s. This is breaking the sound barrier carefully, logically, methodically, safely, to push the envelopes of aviation further. That is what a test pilot does. So that's the end of the lecture. Thank you very much. Everything's good. The problem being, we are in a different space now. So the question and the challenge that test pilots and flight test professionals are going to have to deal with is not the 1960s, 1970s. That still exists, as we've just seen. How do we prepare aviation, defense procurement, and strategic national interest to get after very, very quickly developing innovations in aerospace? And that's the question. Are we preparing people for tomorrow if we are preparing them like we did yesterday? So this is me. I'm Commander Ian Houlston, and I've been the commander for about 2.5 years. So rotary wing background, and it's been a privilege to be the CEO of ETPS. I haven't managed to fix this problem. I don't think this problem will ever be fixed. The question will never be over as to what a test pilot is. It will be an enduring one, otherwise we're not doing our jobs. But the challenge remains, and it's one that we have to try and work with. So, this is a document, which hopefully you've all read, which is the Expendable Remotely Piloted Vehicle for Strategic Offensive Air Power Roles by the US Army. And it basically says, the future holds an accelerating ascent of changes, technological advancements, and potential threats never before imagined just a decade ago. Many lessons of the past may no longer apply to the vastly different conditions of the future. However, past experiences provide the foundation from which we can undertake rational leaps of visionary faith. Hopefully, these attempts will land on firm ground to reveal accessible approaches to meet future challenges. Military visionaries must have open minds to explore new ways of applying the military instrument of power. We can no longer simply adapt to the changing environment with belated upgrades to existing military systems and strategies. Now, in the context of today, that absolutely rings true in terms of the need for rational leaps of visionary faith and not the belated upgrades of existing military programs. The problem is that this was written in June 1996, which means I don't think we would recognize that as having been achieved. I don't think you could recognize that as ever really being fully achieved, but we need to achieve it better. So we need to achieve a solution of what is flight test, what is a flight test professional, what is a test pilot, in order to get closer to that, not getting the laugh it got when that date came out. So we need to get after this. And I'm going to bring in something out of aviation. So this is the Mercedes Formula One team. And we were very lucky with the Aerospace Warfare Centre to get a brief from one of their main engineers as to how they are producing a winning strategy. And what they said is it's not about the car. They don't measure their success in seconds per lap. It's not about how fast their car goes. That's what we see, but that's not what they're interested in. There's progress. They might start the year with the fastest car, but it's all about whether they can make their car faster at the next race. So it's all about measuring seconds per lap per race. But progress is not what they're after. That's not what's going to win. They go further down the rabbit hole with seconds per lap per race per race. Can you progress faster than the other team? And so where we sit in terms of test and evaluation and our challenge of trying to train people to make that work is we need to look at seconds per lap per race per race. We need to have the capability and infrastructure, but also people in their education, upskilling and experience to be able to react quicker than somebody else. We can't just be focused on the thing, the equipment. We have to be thinking about preparing our people to be able to do things faster than other people. It's not about what we can buy, it's about what we can achieve. And this is what we're trying to prepare people for. So we're preparing them for things that could be a strategic, multinational, decade-long, high-value and exotic military capability, like a 6th-gen fighter. We're also training people for a high-value, high-cost, potentially still dangerous, armed, uncrewed air system. We're also having to train in that space a high volume of cheaper, still very important uncrewed air systems. So how do we get after that, that first document in terms of the visionary leaps of faith across all of that spectrum in one school to try and teach people to get after that problem? And so this, and I won't read the whole thing out because you've already heard enough of me reading, but ultimately this is what a military test pilot is, according to a reliable source. The key element for here is, and I'll pick up some words now, this was written by me on the train coming here from Poole. This is my opinion of what a test pilot is. Other opinions are available, and there is no defined, this is what a test pilot is. So we're trying to get after a problem using a key whereby there is still significant debate about what a test pilot is. So we have to try and understand ourselves what we need a test professional to be, because that is only really my opinion. But for me, the key words is that the test pilot is a professional. And that's a strange word that either doesn't prick your ears up or does, because a professional in the military context can be quite different from another military service person. Because for me, a professional is somebody whose integrity and loyalty is not just to his employer, but is to a professional code of conduct, a professional endeavour, a professional community. That's, for me, what a professional is. That is rank agnostic. That is only really answering to the professional endeavours of the cadre. It is someone who represents the operator. So it's a test pilot is someone who has to be doing the job to make sure that the person who coasts out at night into a fight has the equipment that they need to have an operational advantage. So they're not there for the manufacturer. They're not there for their first reporting officer or for the delivery team of engineers. They're there to represent the operator, the 23-year-old coasting out with 500 hours of experience. They have to do this by championing with that professional integrity the facts. Everything that we do in flight test is about facts. We try and remove opinion as much as we possibly can, as much as we don't want to. And it's all about representing that role experience. You cannot do this in this endeavour if you don't know what it's like to strap an aircraft on your back at night on a ship, if that's the role. You must know what that feels like to represent the operator. And you've got to be a leader. We've already seen in 1996 we couldn't get after that. We have many, many individual wins in procurement and many, many individual failures. We need our people to be leaders. I've labelled facts again, because New York is so impressive, everyone named it twice. Facts are double important. Everything that we do is about facts. But as a test pilot, as a test professional in the air, you must get those facts and survive for the next day. You've got to survive. You've got to survive the program. You've got to survive the air vehicle. You must do this in a safe way. Get good data, good facts, but survive. That's what we're teaching test pilots to go and do. Now, there's a lot of words there, so I've turned them down to only 3 now, which is data-driven diplomacy, the 3 Ds. So it's data, everything is data, but the data will do nothing if you don't fight for it. So we are teaching people to represent that data, to get it safely, but we're teaching people to be diplomatic, to be leaders, to be managers. So that's what we as a test pilot school are trying to achieve, is data-driven diplomacy. Now, I didn't come up with that. I wish I did. What I came up with instead is we inculcate a state-sponsored personality disorder. And anyone who knows test pilots and flight test engineers, or certainly if you're married to one, you understand what that means. Yeah? Burning the toast is never our fault. It is a problem with the toaster. So that's what we're trying to do. We're not just teaching an academic content and theoretical knowledge. We're changing the way people think about aviation so that they can represent data as a professional with diplomacy in order to get after what we still can't seem to get after. And we have to be a bit strange in order to try and do that. But we're still test pilots. We're still pilots, test pilots. We can't not do that. We can't throw the baby out with the bathwater by trying to be something else and ignoring what test pilot is. And so I've tried to, again, list what I think are the 4 key things to explain to someone what a test pilot is. You've got to action test cards whilst operating an aircraft, which sounds really boring, but ultimately you are operating an aircraft, potentially out of sequence, getting the data while still operating out of your normal standard operating procedures is difficult. There are huge risks in trying to do something that is out the norm of your normal training. And that is a key skill that we are trying to teach people throughout 12 months at the Empire Test Pilot School. Because what you're trying to do as well is you're drawing a graph in the sky using an aircraft. You aren't flying it the way you would normally fly an aircraft. You are trying to achieve a specific capability or outcome in a role or a mission. What you're doing is you're putting the aircraft in a very specific configuration such that you are then drawing a graph using the aircraft. You are letting nature and physics take over the aircraft so that you can characterize what that aircraft will do, draw the data out of an air vehicle so that you can understand the characteristics, the scientific characteristics. People don't normally do that unless they've had some kind of heart attack or stroke or something in the cockpit, whereby they will let the physics of the aircraft simply take over. And so we're training people to fly an aircraft like no one else flies an aircraft. We're doing this whilst doing simultaneous analysis. So we're running a test card. We are allowing the aircraft to draw a graph in the sky safely, and we're doing the analysis in the cockpit at the same time. We are trying to train frontline crews how to try and do this again and again and again, knowing that the next test point on the test card has never been done before. That's the challenge. The main challenge, and the reason why ETPS exists, is because of the last one, which is you need to be in control of your last test point. And that means the last test point is the one you do before you go to the bar, before you retire, and not the one that you inadvertently did because you crashed the aircraft, or you broke the aircraft, or you broke the program. You need to make sure that your last test point is deliberate, and therefore we need to make sure that people are approaching the edges of envelopes, beyond the edges of envelopes, in a way that they will still come back. And they'll come back with a program that's still intact, an aircraft that is still working, and with them still in the sea. That is the test pilot. That's what it's always been. It's what it needs to continue to be. But we now need to get after this. So this is a very sort of boring looking thing, but what it effectively says is what we've been doing is we took 5 years to get a concept, 5 years to manufacture something, and then we've done a little bit of improvement. And that's taken billions, and it's taken years. What is now required of us in order to get after that problem, that 1996 paper, is to do rapid acquisition and make it good enough. How do we train people to be critical whilst also stopping it good enough? So what we're trying to get after here is, in terms of the time scale, the GCAP, so this is the 6th generation fighter, we are looking for that to be at the end of the concept phase, so just understanding what we're trying to get after at the end of this year, with the initial operating capability at best in 2035. That's 10 years. The time in between the first Lancaster flight and the first Vulcan flight is about the same. So that kind of pace of change between one manufacturer, one piston-engined bomber, and one jet-engined nuclear bomber, that level of capability change is the same as us going from one part of that to initial capability and in service. So we must be doing this faster. But the problem is you've got less time, which means are you going to get less data, which means you're going to need more diplomacy. So again, we're talking about teaching leaders rather than just teaching people how to fly. And the other problem is the military can take this, but we're producing test pilots who may do 3, 4, 5 tours in the military, but may then be the future champions of UK strategic aviation interest. You need people who can do the full safety process, because those corners to cut you can't do if you are going to be representing a major commercial air transport project. So we need to train people for the top line, the bottom line, the top aircraft, and the bottom aircraft. And that's the challenge that we need to try and get after for that. But also for this. Because one thing about, and I know that this is the Royal Aeronautical Society, but we do this really well. We train people for over £1 million per person for 12 months to go and assess a P-8 Poseidon, which is bought commercially off the shelf from the United States and is a Boeing 737. We probably put £2 to £2.5 million worth of training in the team to deliver that for us. These programs, which are equally important for defence, we struggle to get them to spend £5,000 to upskill people. So we need to not just answer the question for us, because the future of the capability is not going to be in a single aviation platform. It's going to be in the entire network of capability. So we don't just need to train test pilots and flight test engineers. We need to train test and evaluation for defence. So that's another broader question, which I won't go down the rabbit hole for. Because we also have our own challenges in flight test, which are, do we need a different test pilot? Do we need the Chuck Yeager test pilot? Do we need more in the program management space? With the synthetic, we're constantly being told that the synthetic data that's coming out of the manufacturer is assured, which means that when the test pilot does the first flight, they're not going to find anything interesting. It will be as briefed, it will be as per the brochure, it will be as per the sim, it will be as per the model. So it will be good out the box. We can de-enrich that testing of what a test pilot is in order to free up the capacity to turn them into something else. A lot of these aircraft now will have a capability, so if you need to fly a certain very, very accurate and precise profile, you press a button and the aircraft will fly it itself. Do you really need a test pilot anymore? What does a test pilot do in that scenario? Other than you have an unassured flight control system flying a new, novel, unassured aircraft, the only thing you probably have in that is the assured pilot, the person who's been trained enough in their adaptability to deal with problems, to actually sit there, analyse in live time to understand where the problem might be. Too much reliance on system assurance, assuming that the test pilot doesn't have a role in that, is potentially a catastrophic fallacy. They could try and turn us into complex systems experts, which we'll look at. Program and requirement managers, very, very important. A test pilot can change a program, but that isn't necessarily what a test pilot is. That's some of the attributes a test pilot can have and that we need them to have, but that isn't necessarily what we train them to achieve. And what happens when the pilot is optional? Is a test pilot optional? Don't know. So, modern battle space, highly complex, integrated systems. We need a test professional to fully understand the complex systems in order to know what the effect for the frontline operator is going to be. Do we need this to be a test pilot? Do we need to de-enrich the core test pilot skills so that we can free up the space for them to be very specific systems experts? Because people will spend 10, 15 years becoming subject matter experts in this field. As things have become more and more complex, can we really de-enrich those core test pilot skills in order to satisfy this requirement? I would say no. But do we need a test pilot for this? So this isn't a multi-billion pound program. It certainly isn't a multi-billion pound platform. It may cost £300. Do you need a test pilot? Looking back at what I said a test pilot was in terms of data-driven diplomacy, does it work? Does it do what the operator needs? Is it going to give us an operational advantage? That question could be more important for this asset than it is for an exotic billion-pound asset. Because you could be buying thousands, and this could be your strategic eyes in the sky. So just because it's cheap doesn't mean it's not important. Do we need a test pilot? And then we have things like this. So this is the idea, which I've learned from Rolls-Royce, from talking to them, of engines where the computer that runs the engine, the fuel management system, can effectively rewrite, or potentially rewrite its code in flight. So that it effectively knows itself better than anyone else does. So to optimize its efficiency, could rewrite its own software in flight so that the engine that you took off with is different from the engine that you land with. How on earth do you test it? How do we train people to get after that? I don't think that there is a problem like that has existed in flight tests so far. So how can we, who barely understand how this is emerging technology that is going so fast, how do we produce a school that can get after this problem? Because all we do, well I say all we do, but what we do is we teach a philosophy. Understand the system, design a test, and report. So what you need to do is you just need to understand the system. How can you understand a system that is redesigning itself in flight? How do you understand a system that is non-deterministic, where what you do, if you do the same thing every time, you get a different outcome? How do you assure that? How do you test it? How do you train people? How do you prepare people for that? We just don't have the answers to this right now. This is what we do. We've got a fleet of shiny, painted, civilian aircraft, purpose-fitted to teach test pilots. We're teaching them all the classic flying qualities, systems, risk, role relation. We're teaching that universal tester that is the Chuck Yeager tester. We are struggling to get hold of innovative access to innovative, quickly changing technologies to prepare people for what they might face when they graduate from our courses. Our course is 12 months long. The pace of change of technology is that the capability when they graduate could be fundamentally different from the one when they joined. How can we produce a course to train people for that? Because all we're trying to do is get after the problem and help people to help us do that. So this is what we do. This is, if you're interested, it's about, I won't go into exact details, but it's over £1 million. If you're interested in 12 months of joy, you can join us on the test pilot course. You need a few prerequisites beforehand, like a couple of thousand hours of fast jet. However, what we'll do is we'll turn you into that state-sponsored, personality disordered problem child who can take an aircraft that is entirely well-known, like the Alpha Jet, and in 6 flying hours and 5 days of writing can produce about 120 pages that look like this. So this is not quite assured, but this is the data represented accurately and compellingly to say that that aircraft can't do the role that we asked it to. And so after 12 months, we take people who've never done this, who've only flown one aircraft type, to fly an aircraft that they've never flown, and within 5 days of writing and 6 hours of flying, produce a fundamental character assassination of the aircraft for the role that the manufacturer cannot really argue against because it is driven by data. That's 12 months. We're not going to be able to answer that problem with £1 million per student 12-month course. So we've got to do less. And you're going to get less for less. But we need to still do the same thing. We still need that scientific analysis. We need to breed that mindset of data-driven diplomacy whilst testing cheaper assets. And so we're still trying to get after this with a shorter course. And even still, we have the Aldi version, which is the 1-week course, where we're still getting after the same issue. We're still trying to represent the data with a professional integrity, representing the operator. We've just had a week's worth of training, but we're still trying to get after the same thing. Because really what we need to get after that Mercedes problem is we need mass. We need a large group of dedicated people who have got knowledge, deep systems knowledge, and we need to give them flight test knowledge. We need to give them aerospace knowledge. We need to give them that broad test experience where you can't afford £1 million in 12 months. So we need to bring these subject matter experts, these high-value people into the industry, but we need them to think like testers. And so this is what these short courses are for. And our challenge, so ETPS, things that we need to get after, is we are flying a civilian fleet. Kinetic, which is a civilian defense company, is effectively running ETPS. How do we get access to these kind of emerging technologies? In some cases, the civilian market will be driving this innovation. In many of them, it will be the military. How do we, as a civilian school, get after that for UK defence? We are regulated. We are a training school, effectively the same as if you went and did a PPL somewhere at Thruxton. That's the school. We are designed to not change our syllabus. We're designed to deliver a set course, to receive a set qualification. How do we get after this rapid change of innovation if we have a system that stops us innovating our course? Regulations and global trading needs. Things like uncrewed air systems, we don't even have a regulation that says what we need to train to. So if the regulator doesn't know and the customer doesn't know and we don't know, how are we going to create training? It's definitely putting the cart before the horse, but somebody needs to move first in order to make sure that people get after this. Even the classic of training jet test pilots, we don't have two-seat jet aircraft these days. There's Typhoon, there's a few F-16s still around, but in general, everything now is a single seat, F-35, F-22. How are we going to give people this test experience when it is not in a live jet aircraft with an instructor? And as we said, we're looking to try and make sure that we are producing a value for money, because if we don't, people won't come, people won't get the training, and we won't be preparing people for the challenges that we have ahead. An input-output standard. The standard for a test pilot for 12 months is about 1,000 hours with hopefully multiple types, generally a degree in engineering. The people who are going to go after and have experience of small uncrewed air systems, we can't assume that they're going to have that level of background. The same experience and educational background that have always been feeding the test pilot world will not really be available, but we still need them to do the same thing. We still need them to represent fact. and to represent the operator. So we need a course that's not only going to produce them to the right standard, but will accept them at a much, much lower standard. And the opportunities. Approved training organisation, very fixed course. Maybe what we need is more of a research mentality, one where we actually train people more on the job, more embedded with an industry that is actually getting after the problem, rather than in a school environment. We are clearly going to need to use synthetics more. If we're not going to have access to fast jets, we need to start building in simulators. Airworthiness, yes. How do we make sure our people are safe? These aircraft are phenomenally safe, but they are not at the cutting edge of innovation. We need to make sure that we expose people to innovation, but with the drag factor of showing that we are safe in doing so. And the last point, which I'll just skip to the last point, really is fixed wing, the rotary wing, uncrewed air system, things like electric vertical takeoff. More now than I think pretty much any time in the last 80 years, things are fundamentally changing in terms of the delineation between fixed wing and rotary wing has closed, whereby the modern uncrewed air system or the modern eVTOL will be neither one nor the other, or it will be both. How are we preparing people, rather than stovepiped, to address what is going to be a phenomenally complex problem, whereby it's difficult to answer what training will lead to what outcome. So I'm just going to return to this document from 1996 and say, these are the challenges that ETPS has. I think the changes in the last 5 years and in the coming 10 years are going to be different from the last 80. And it is time for us to really get after this. And I have no real idea what that looks like. So again, in the last 15 minutes, it'd be good to get some answers. Because this is our mission, and it remains our mission, which is still to impart that knowledge and ethos to produce leaders of safe and effective aviation trials, and most of all, to secure that enduring advantage in combat. And this is the last time I gave this, which showed in the career of one test pilot, where first project, last project, that's the innovation, that's the speed, that individuals who were trained on the left applied those skills all the way onto the right. So the question of, are we training people for that 6th gen fighter? The answer is yes, because we trained the same as the person on the left to do that on the right. Are we training them as best we can? Probably not. And that's what we need to get after. But thank you very much for listening to my problems. I have a piece of paper and a pen, and I'll be very, very interested to know what the answers are. Any solutions?
Thank you. We've got some microphones coming around the room, so yeah. Sorry to make the run everywhere now.
Thank you very much. My question is, the students from year 1, do they become the flight instructors for year 2?
For our
They've
course.
already learned more now than their instructors.
So from the uncrewed air system space, which I'm very, very keen on developing, that's exactly the mentality I want. What I would like is for our instructors to be very open to say, we know about test and evaluation, but we don't know about this technology. So therefore, learn with the students. You want the staff, and it's better for the staff, to be learning and be professionally developing themselves with each course. And each course, the staff will upskill, the students will upskill, and the resource, that Mercedes capability that we're talking about, is embedded in the teaching. So that's exactly, you would want those people to, they probably then need to go and develop their skill in real test and evaluation. But absolutely, we would want those people back in. But really, I want the staff to be learning with the students. I want them to be learning from each other, because the staff will learn as much about this new technology from keen 25-year-olds as the keen 25-year-olds will learn from the staff. We've got to do that together. And so, absolutely, I would expect this to really grip the innovation. It cannot be instructor-student. We have to accept that the students are going to rapidly outpace the knowledge of the instructors. Yeah.
Thank you, Ian. Thank you very much for that. It was really interesting. Peter Eady, I'm a former army pilot, but not intelligent enough to become a test pilot.
You just don't have the state-sponsored personality disorder.
Yes.
Be kind.
When you were talking about the future test pilot for any type of uncrewed system, remotely piloted systems, optionally piloted systems, I was just thinking about the role of artificial intelligence, and it's one term I never heard you mention during the talk, and I'm wondering whether artificial intelligence will gradually perhaps replace the role of a test pilot, perhaps in the uncrewed space first, and then potentially in the manned space later on. I know it lacks the battlefield experience and the intuition, but can that be trained into it later on?
So using AI in the test space, so getting after AI in the test space is going to be critical. So one thing I glossed over was the change of getting data. So the way that we've always got data is we have drawn that graph in the sky. So we draw a very, very specific graph. AI can take the entire flight test instrumentation data from a flight. It could be a frontline flight. It could be any normal flight, and regress that data to draw those graphs. So you effectively can get an entire test campaign almost, so worth of handling characteristic data from AI crunching that data. In terms of tuning handling of uncrewed air systems such that AI can tune it so that it can predict what the outcome of a change would be, fundamentally is going to be quicker than using test, and using crewed test. You just need to understand how, or the testers need to understand what the AI has done so that it can be assured in terms of its output. But actually putting the live tester at the end, so at the start and at the end, and having AI do the tuning and the development of it is critical to making this happen fast. But again, we can't train our test pilots to be AI experts. The AI experts take 20 years to become AI experts, and then 1 year later, if they haven't continued, they're no longer AI experts. So we need them to be the experts, but that doesn't mean that they know about test and evaluation, and it doesn't mean that they know about the front line and the operator. So we need those people to be embedded and be used by flight testers. But we need the flight testers to know the language. We need them to understand what the cautions and the limits of AI are, given that those are changing rapidly as well. How we thread AI into flight test, as well as into the capability itself, is a huge challenge, not just for us training, but us how we use these sort of capabilities. Again, that's just another question that I even more don't have the answer to.
There's one behind.
Are we on? Right. Thanks, Ian. That was a great presentation. Guy Adams from Australia. As a FTE graduate of the school from many years ago, I certainly believe that the requirement for test pilots and FTEs will remain for a long time in the future. But we also send people to the US to train as what we used to call flight test navs / flight test system specialists. When you referred to that kind of system of systems, not just the aviation part, I've always felt that the role of the FTSS was probably becoming more important over time, and that we should increase the volume of those. Is ETPS in the UK looking at standing up a course to support that at all?
So we did, weirdly. We designed a modular course, the aim of which was to delve deeper into the systems test. We have an RAeS systems course, which is 12 months of master's level systems training, but it doesn't really involve much test and evaluation. So one of the problems that we have in terms of preparing people is we can't train them for a specific system. So we can't train them for X radar or this weapon system. We have to teach, because it's unbounded. We have no idea what they're going to be faced with. So we have to teach them a methodology of, a methodology of how to approach the problem. Where we, with the engine that's redesigning its software in flight, the problem comes when that methodology breaks down, because there's a key part of it that you can't do. So what we did is we delivered a systems test course, but in the way that was constructed, it ended up being about 4 months long. So we were training people for the harder question with a third of the time. So nobody who's trying to get after that is interested in a 12-month version of that. So people need to see the need for there to be a course. What we did, and I think this is the future of how to get after this question, is we turned that unused systems course into our uncrewed air system course. Because actually, it's just integrated systems, complex. That's where your AI is going to come in. That's where your innovation is going to be. So if we're going to teach systems, we might as well teach it through the medium of uncrewed air systems, because that's where we need to be able to focus. And the long courses, I'm missing the best way to say this, they're 82 years old. They have a lot of inertia to them. So I say that the definition of a test pilot is mine, because if you went round ETPS and asked for a definition of a test pilot, you would get 25 from 25 different test pilots. The course isn't owned by me. It's not run by me. It seems to be owned by a collective cadre of unknowable test pilots who live in the world, who slowly own this unseen leviathan that is a badge that says that you're a test pilot. That is a real strength of what we do, but it's also a massive problem for getting after innovation, because it's not owned by a requirement to get after something. It's owned by this spectre of being a test pilot. The uncrewed air system in the systems course is free of that. It's not £1 million. It's not 12 months. That's where we need to try and focus innovation and flexibility, not just in terms of what we're teaching, but how we're teaching it as well. So, yes, but the answer's 12 weeks rather than the... it's not going to prepare people for that slide with an F-35. The only thing that's going to do that is a team, and a team of young, very, very intelligent and experienced. So if you know any really, really young, experienced people, we'd love to hear from them. So no, but that's another thing I'll stick on my list for stuff I still don't have an answer to. Yeah. No one is really helping.
So, talking about the length of time everything happens, one of the things that takes a long time is to clear new weapon systems for aircraft. But then suddenly when there's a war to be fought, it happens in weeks or months. Are there lessons to be learned of? So how does that happen? And is it a risk? Is it a higher risk acceptance? Or what happens to suddenly suppress that time? And are there lessons to be learned?
So it's absolutely... an elevated level of risk that's being accepted. So a great example is the Sea King Mark II. We had no airborne early warning during the Falklands. So that gap was there when the Falklands started. Suddenly, a radar system with British gas piping appears on the side of a Sea King within months. That's incredible. We've just done the same thing with the Merlin and Crow's Nest. It took about 4 years. So risk drives everything. And one of the things, by putting on the land and sea component, one of the things that we need to understand from an aviation perspective is that, yes, we assess risk well, but very often the mitigations that we apply for ourselves have increased risk to the people on the ground or the people at sea. So we will mitigate by making sure that we have an extra £500 of fuel, But what that does, whilst giving us another veneer of perfect safety, is reduce us giving close air support over people for an extra 30 minutes. So we need to understand where our risk is as aviators, and where we are being too risk averse in our domain and pushing the risk up to other people, which is where we sit differently from the civilian commercial air transport side, where there is no good enough. There is only certified and the highest levels of safety. So what we need to do, and it's, I briefed the Challenger 3 team on this a few weeks ago. If you want to do it quickly, you need to know the rules to break the rules. So if you're going to try and do something quickly in an emergency for operational reasons, it's easy just to say, well, we're just not going to do it anymore. You need to know which bits you're going to triage. You need to know which parts of the test you are going to do to best inform you, because the data, the physics of the system will be the physics of the system. The risk will be the risk. We just need to know how much of that risk we can possibly know given the time that we've got. And that's for people's, luckily in the world that we have at the moment, that risk is held by individuals and managed by individuals, and it's being managed a lot better than it used to be. But it's still very, very slow. So we need to get after that. But again.
Any more?
You said in one of your slides your output is very dependent on being part of the team, part of the procurement team. Given the MAA's recent emphasis on developing a safety case with the through initial gate and main gate, are you finding you're being invited in earlier? And is there an interest in the test pilot community to get in earlier?
So that last one, easy, yes. We desperately want to get in earlier. We very often are not brought in earlier. And we're very often not listened to, which is where the leadership and the communication comes in. So the example I give to the students is, and this comes from my own sore experience, having an extension done on your house. You're the customer, you have hired a builder. When the building regulator comes round, you generally stand on the side of the builder, and you don't want him to find anything wrong, and when he does, you both attack him. You both want him not to find any problems, and when he does, you want them swept under the carpet, or at least I did, because you know it's going to cost you more money, more time, and this is my house that my family live in, and he's telling me that I'm not being served properly by the builder in terms of my extension. Now, what we find in procurement is that we are the building regulator. We're turning up to the project team, explaining that this plan is not an appropriate plan. It either doesn't meet this or it doesn't meet this, and we're protecting the customer from the complexities and the realities of a program. And what we find is that the project team and the design organisation and the OEM, so the manufacturer, they gang up against us. And if that happens early, they're allowed to, or they are more predisposed to ignore us because they can. Towards the end, when we're doing independent technical evaluation, they can't ignore us. And then they wish that they'd spoken to us earlier. So yes, we try to. The problem that we sometimes have is that we're requested to solutionize early. And we train our test pilots and flight test engineers not to solutionize. And we do that almost as a matter of principle. Never, ever solutionize. That doesn't mean that you can't give some steers, but never own the solution. And I've watched the industry people here looking at me like they hate my guts. But if you break it, you own it. So we can do a laser focus analysis of a deficiency, be that in the article itself or in the program and in the test plan, in order to try and uncover what the characteristics of the article are. But we can never say, you should do this. Because if we do that, the manufacturer will do that, knowing or not knowing that it's going to cause a problem in 2 years' time, which we now own. So we just need to be laser focused in our analysis and communication of the deficiency as early as we possibly can. But if you get in too early and you start to solutionize, you end up with a program that isn't working that has your fingerprints on it, if that makes sense. That's from my experience. Mark's
Time
not
for one more, probably.
Hello, good evening. You mentioned on one slide a lot of new aircraft that we're starting to see in the market, starting to emerge from the uncrewed side to some of the eVTOLs, weird and wonderful shapes, different propulsion systems. Just out of interest, where are your graduates going, and how does that feedback loop work with the flight schools?
So we've got from our Class A course, so 12-month, £1 million, we've graduated a crewed test pilot to go straight into the Protector program. So the question of how do you get a test pilot for something like Protector, so that's a very, very expensive, certified, it's effectively a combat aircraft without a pilot in it. How do you get someone with role experience who can represent the operator, but who can do a test pilot course that requires you to have 1,000 hours P1 when RPAS doesn't count? So we need to find people who are either going to be flight test engineers who can go into that world. And I personally think that flight test engineers are underutilized in that space. They're effectively trained in exactly the same way as we would a test pilot. They just don't have to have the skills in the cockpit on the controls. But training crewed pilots to take over programs like that is currently what we're having to do. So we're feeding back and we're getting feedback from things like Protector, but that's still very, very much at the top of the complexity. What we're not getting at the moment is the feedback from our uncrewed air system course, where people will get experience of testing 15 products in a year rather than one product over a tour. So that's where we can get quick feedback, where we can get the innovation back into our school. But we've only done the course twice. The regulation that said that when they got qualified, that qualification meant anything, only happened 3 months ago. So we are still very much right at the far edge of the envelope of that course being anything at all. So feedback is going to be fundamentally important, which goes to your point as well, which is we need to be learning during the course, not 18 months after the course. Our current feedback cycle is we ask our students if our course prepared them 18 months after they leave. 18 months after they leave, the technology's moved on. So we need that feedback every second of the course. We have to be learning and training with them. And therefore, to really get after the problem, it needs to be a research and development university postgraduate style learning. One where you're learning with the professor. In that case, I'm a professor, but I'm not a professor. Really difficult. How do you get that feedback that fast? Because speed is everything, but speed is less data, unless you can throw AI at it. So then, and the thing that we're getting after, someone else is also trying to get after. So we have to do this better than they do. Because you need to survive the first few months. After that, it's going to be about how quickly we can turn around this loop faster than someone else can. And we're seeing that now.
Thank you. Thanks, Jim. From my perspective, listening, initially I think a mixed emotion about time on the course. I saw some real, so it's like the Alpha Jet Transonics in particular comes back as a memory. But I think the point that was made towards the end there about the your building regulator analogy, in my own experience of 15 years since graduating from the school, that challenge, I'd say the challenge for the ETPS students is sort of articulating the value that can be added at the outset, irrespective of the perceived cost as opposed to the real cost. I think it's been an ongoing challenge, and I think I look around the room, they're dotted around here, some of our industry colleagues that we just had our committee meeting with before, probably every single one I'm sure would agree. It seems to be almost an unsolvable problem, but I think the skill of articulating why it's important to do that analysis and do that thinking of the scenarios and the outcomes, etc., right at the start, how it will save, that exponential graph, how it will save the development costs and the program later. So, but thank you very much.
No, thank you.
Round of applause for Ian.